Refrigerators are an invention of the 20th century. In medieval times, long distances had to be traveled in order to get ice and snow to keep food fresh. All modern fridges with a compressor work in the same way. A container, made of plastic and metal, is equipped with several insulation units so that ambient heat cannot get into the fridge. A thermostat measures the temperature in the fridge. It is linked to the compressor by a cable. Tubes with a refrigerant in them are connected to the compressor. The tubes are grouped into the evaporator unit and the condenser unit. Evaporator and condenser are connected to each other through a throttling device, such as a tube with a very small diameter. Normally, food placed into the fridge has a temperature above 10 degrees Celsius, and that's exactly where the fridge gets warm. So this heat has to be transferred back into the environment. Heat transfer into the environment is done by the refrigerant, such as isobutane. Before we start examining the whole process, we should talk about three very important principles. The first principle is called latent heat, which occurs at a phase transition, such as water boiling or ice melting. Latent is Latin and means to lie hidden. That is, the refrigerant will absorb heat but won't get any warmer because the heat is stored as internal energy within the refrigerant. The second important principle is the fact that two bodies that are in thermal contact move towards thermal equilibrium. That is, the hot body gets colder and the cold body gets hotter until both bodies have the same temperature. The third principle is the relationship between pressure and temperature. According to Emonton's law, the pressure of a gas is directly proportional to the temperature. That is, the higher the pressure, the higher the temperature. Now, let's talk about the vapor compression cycle. In the condenser, the refrigerant is under high pressure and present in liquid form. The refrigerant has to pass a throttling device to get to the evaporator. Here, the throttling device will produce a substantial reduction in pressure. Consequently, the refrigerant cools down and partially evaporates. The other part of the refrigerant remains in liquid form. The refrigerant flows through the evaporator within the fridge. Now, thermal equilibrium between the inside of the fridge and the evaporator takes place. As a result, the heat is transferred to the evaporator and the fridge becomes cold. While absorbing heat from the fridge, the refrigerant evaporates but doesn't get much warmer because the heat is stored as internal energy within the refrigerant. The compressor is installed at the other end of the evaporator. This compressor will push the refrigerant under high pressure into the condenser. As mentioned before, this will increase the temperature of the refrigerant because pressure is directly proportional to temperature. This heat is transferred to the environment because thermal equilibrium between the condenser and the environment takes place. The release of heat causes the refrigerant to liquefy. From here, the vapor compression cycle starts again.